Hi, my name is Jane Ginn. I'm with the Cyber Threat Intelligence Network. Thank you for joining us for this series on threat intelligence platforms. Today, I'll be showing you some of the features of the TruSTAR Threat Intelligence Platform, or TIP as we call them. The first task I'm going to take you through today is learning how to upload your data or your reports into your enclave on the platform. So here we are at the landing page for the TruSTAR Threat Intelligence Platform. Let me first familiarize you with what you're seeing on this page. We have three tabs: the Dashboard, Explore, and Search TruSTAR, and we have this button up here. I'll take you through each of those four items throughout the course of this tutorial. We also have three panels here that we can scroll to and look at, and we have two drop-down boxes. So first we're going to make sure that we're in my enclave that I want to be in, and we are, and then I'm going to look at all of the reports that have been uploaded over the past 30 days. You can see I have internal enrichment, community enrichment, and relevant IOCs, or indicators of compromise. Over on this side of our real estate, we have trending IOCs, and then scrolling down, we have trending malware and trending vulnerabilities. Now we're on the second tab, or the Explore tab, and you can see that I have several options here along the vertical navigation bar on the left, and I have the ability to filter all of the enclaves that I have access to. Right now I'm only looking at those reports that are in the JG demo enclave, and you can see that my reports are identified here, with the most recent being stacked on top. Now I'll take you into the search bar. I already have an MD5 hash of a piece of malware that I'm going to load here into this panel, and I'll run a search on it. As you can see, we have the three little dots showing me that the engine is processing the data, and once the data is processed, the report will load up where that MD5 hash is showing up. Now, what this is telling me is that for this hash, this MD5 hash, there are 4 reports and this one IOC that are being highlighted from my search. So here we are back at the dashboard, and I want to show you this last button, which is how to manually submit a report. In this particular demo, I'm going to be submitting a report of SEDNet data that's associated with APT28. I first want to click this button, Submit Report. I come up here and give it a report title. I'm going to call it SEDNet Rising. I'm going to give it some categories, APT28 and SOPHAC. And I'm going to now go into this box where I can upload any file less than 2 megabytes, and it can be in any of these formats. It just so happens that the file that I'm demoing with is a text file. So I'm going to drag my text file into this area, and you'll see that it's immediately scanned into this panel. So as you know, the ability of an analyst to maintain confidentiality of the data is really critical. And so this particular tip has a redaction step built right into it. And you'll see that if I scroll down, I see my name here. And if we go now to the next step, if I scroll down in here, that name has now been redacted. I am maintaining a library of redacted names over in this panel that I can simply build through time so that whenever I upload information into the TIP, it immediately redacts it. And then I can also add new items to my redaction library as I work through with all of my various analyses that I perform. Another point I want to make is that we have the ability to submit data to any of the enclaves that we have access to. I only want to submit this data to my demo enclave, so I'm going to X out all of the other enclaves at this point. Now everything looks good to me here, so I'm going to submit the report, and it asks me whether I'm sure, and I say yes, I'm sure. It's now working with the data and extracting the indicators and correlating with other open source data. And what you see now is a graph-based model of the data as it renders within the ThreatIntel platform. So let's take a look at the real estate here. We have this panel over here on the left where we see the original text of our report plus all of the IOCs. We see the tab that tells me that we have 117 IOCs associated with this report. We have 45 SHA-1s, 19 softwares, 48 URLs, and 1 registry key. And then we have 2 pieces of malware and 2 vulnerabilities, or CVEs. We can now move over to this panel, and we see a timeline along the bottom, and we also see an edge and node graph-based representation of this particular SEDNet Rising data as it presents itself in the working panel. Now, I want to show you how very dynamic this is. We have the ability to pull any one of these other nodes into another part of the workspace to move it out of our way as we're continuing to work, or we can simply filter any of the sources that we don't want to see with this drop down here. We can add our labels to the rendering. So in this particular case, we see that this data came in from hybrid analysis public feed, and this is the identifier and the date. We also see other reports, so I can easily move this report to the center of my workspace. I can right-click and expand out that information to dig down deeper into the data. So what we're seeing here now is that I've highlighted this Olympics-themed spearfishing data. And so if I go over here to my panel, I see that there's a JSON file of that I can easily download as a JSON file or as a STIX file, a text file, or a FireEye tap. But this report is beginning to look too busy, and it's very hard for me as an analyst to figure out what's going on. So I'm going to turn off my labels, and I'm going to start moving the time frame forward from 2016, when we first started gathering this data, to a much more current time. And we can see what begins to happen is that the older data drops out, and we're only looking at the more recent data at this point. So there's a few other things I want to point out to you about how the information is rendered in the workspace before we move on. You can see that I can pull this report, which is represented as a blue circle, out of the way so that I can get access to all of the other icons that are showing up here. So here we have a SHA-1, here we have a URL, here we have a SHA-1 with a comment. So if I click on that, we are able to move over to the notes and see that we have a virus total file associated with this indicator, this SHA-1 indicator. And I can very easily go to this file now and see what that malware is and what it's been doing. The next exercise I want to walk you through is how to do basic threat hunting using the TruSTAR platform. So here we are back at the dashboard, and I'd like to now drill down into what an analyst does to try to determine what the threat actor is doing and how the analyst uses the threat intel platform to accomplish this objective. So let's go back to one of our reports that we have been using. Let's go to the SEDNet Rising that I just uploaded in the last segment. So this will open up, and I'm going to click on that box and make it a little bit smaller so that it's a little easier to see the whole thing. And then you'll remember that I took you into the one SHA-1 that had the note attached, that had the virus total file associated with this. I'm going to copy that file hash right there, and I'm going to go into virus total. I'm going to go into search and search for that hash. You can see from the screen that 25 engines have detected this file as malicious. It has a community score of -87. This means that 25 of 58 different engines have detected this. You'll also see this flashing 3 from the community. If we click on that tab, we can see that, in fact, there's some very recent activity from 2017 and 2016 here for this particular piece of malware. We can drill down into the details, see that it's a rich text format. There are a number of different tags. We can see which which two vulnerabilities it has been designed or weaponized to exploit. We can see its compile time and its last analysis time. We can see some other file names associated with it and commonly abused properties. And if we go back to the detection screen, we can see all of the different vendors that have identified this file as malicious. And we can see by the variety of names that have been assigned to this particular rich text file what the various antivirus teams are saying about it. Here we have an exploit that exploits this vulnerability, a generation B. We have a heuristic exploit that's associated with a Microsoft Word document. We have this vendor calling it a Trojan from 2015. We have this vendor associating it with a particular dropper. We have this vendor noting that it's a Trojan and an exploit, and so on and so forth. So you can start to gain a little bit of an idea about what that particular piece of malware is doing just by looking at the names that the various antivirus companies and malware researcher companies use. Now, what the analyst would typically do is that they would very systematically go in and look at the software and all of the different SHA-1 files associated with this report to try to piece together exactly what that malware is doing and how it's being dropped onto the victim network or target machine, how it's being used once it's on that machine. Is it being used to move laterally through a network? Is it being used to download a rootkit onto that machine? There are many, many different options and scenarios. And it's the analyst's job to now drill down into each one of these modules and try to pull together the various pieces of the puzzle to determine what that particular piece of malware is doing. Another thing I'll point out at this juncture is how the associations with various reports can give the analyst a clue about the malicious infrastructure that the threat actor is doing, and therefore can help the analyst determine what the goals and objectives of the threat actor might be and what exactly they're after. If it's espionage, industrial espionage type malware, then the analyst might then deduce that they're after confidential drawings or blueprints or research findings of a particular organization. If it's associated with point of sale for, say, a retail outlet, then the analyst might conclude that the threat actor is looking for personally identifiable information. If it's associated with a piece of malware that's been exploiting hospitals and clinics, then the analyst might then conclude that the threat actor is looking for very rich data associated with the health records of particular individuals. You'll see at this juncture that I have highlighted this Unit 42 report, and over in this screen we see the description of the analysis that was performed by Unit 42 that points to how a particular piece of malware that they called SED uploader was connected to this SEDnet malicious infrastructure that we are looking at, and how that was being used as a way to target European government agencies. So this is really just a very quick look at how an analyst uses the TruSTAR platform to perform their various analyses and try to move towards some sort of reasoned conclusion about what is happening on a network or on an endpoint, what kind of malware is being used, how it might be connected to historical malicious infrastructure, and then convert some of these indicators of compromise, some of these atomic level indicators into actionable intelligence. So now let's learn how to save our threat hunting excursions as cases that we can share with members of our team so that we can all work in parallel. So here we are again with the SEDnet Rising data, and I'm going to go back into the report, because what we're going to try to do now is take a look at how to save this data as a case that we can then share with others. I'm going to click inside of my workspace and minimize this so that we can begin to see it. And in order for me to have something valuable to share with my team, I want to first show you how I typically upload data that would be shared as a signature to my network defenders, like, for example, a Yara signature. But in order to do this, let's go into a little bit of background on what the SEDNet malware family is all about. The SEDNet is actually a synonym for APT28 or SOPHIC, and is another way of characterizing the work of this large, well-funded, and well-resourced hacking crew. They've also been known in some nomenclatures as Fancy Bear. It's a group of attackers that have been operating since at least 2004, and their main objective is to steal confidential information from very, very specific targets. We've seen at least 1,000 very high-profile individuals targeted with their various phishing campaigns. Their targets are typically Ukrainian officials, political dissidents from Russia, NATO officials, and during the U.S. elections, the Democratic National Committee. SEDNet also operates, as we can tell from compile times and other artifacts, they operate during UTC+3 time zone, usually on weekdays. So it is an indication that it is a well-funded, normal workday for individuals in the Moscow time zone. We also know that SEDNet has developed their own exploit kit, and that they use quite a few zero-day exploits when they're attacking their various victims. And one other distinguishing characteristics of the SEDNet group is that they have developed first-stage malware designed to bypass network security measures so that they can obfuscate their activities within a network. What I'm going to be showing you today is a Yara signature for Xtunnel, also known as XAPS, that is designed to help network defenders ward off any kind of attack by the SEDNet group. Just to give you a little bit of background on this tool, Xtunnel is a network proxy tool that can relay any kind of network traffic between a command and control server on the internet and an endpoint computer within a local network. It uses the infected machine as a network pivot to contact machines that are normally unreachable from the internet. So we're sitting here with visibility into our workspace with the SEDNet Rising data, and I would like to open up a Yara rule that I have here from a group called Netzpolitik, and it's regarding a SEDNet attack on the German parliament in 2015. It was written by this author, and it's aimed at this project XAPS, which is a synonym for Xtunnel, which you can see later here in the Yara signature as an executable. So we have this Yara rule here that we want to pass on to the members of our community that are in our enclave. And so I'm going to copy all of this signature and minimize that. And then I'm going to come into my notes panel that's associated with my SEDNet Rising, and I'm going to paste that in there. So now, when anyone comes to this particular location, they'll see that I have this note that's in here. And they'll also see, if I click back in here and enlarge this, you'll see the little comment button. So when I click on this, they'll see here that there's a note that has the YARA signature. So this is a way that threat intelligence analysts can actually make the information actionable for the network defenders when they pass it on. And so when I am in this tool and I decide that I want to send all of this information, including my YARA rule, to the rest of the team, I can go up here to save, and I'm going to give this a case name. So I get the signal here that the case was saved, and now I can go to Explore, go to my cases, and see that there it is. If I go back out of this to Explore, I see that I have an icon here that is a little envelope icon. I can now send this off to a colleague of mine who then is able to take action. So with that, I'll end the tutorial at this point, and I'll look forward to having you view some of our subsequent tutorials that will take us into more advanced topics. I hope you found that useful, and I hope you have a chance to use it to your advantage. Signing off, Jane Ginn, Cyber Threat Intelligence Network.